Electric dipole. Electric dipole is a pair of point charges with equal magnitude and opposite in sign separated by a distance. Many physical systems from molecules to TV antenna can be described as electric dipoles. A water molecule is an example of an electric dipole. Even though the water molecule as such is neutral, the chemical bonds within the molecule causes displacement of charges. This displacement of charges creates a dipole with a negative charge on the oxygen end and a net positive charge on the hydrogen end. If water molecules were not electric dipoles, water would have been a poor solvent. Subtopics. The field of an electric dipole. A. For points on axial line. B. For points on the equatorial line. The field of an electric dipole. Electric field produced by a dipole is known as dipole field. Let plus Q and minus Q be equal and opposite point charges separated by a small distance 2L. The strength of an electric dipole is measured by a vector quantity known as electric dipole moment P bar, which is the product of the charge and separation between the charges, that is, P bar is equal to Q into 2L. The direction of P bar is always from negative to positive. The SI unit of dipole movement is Coulomb meter. A. For points on the axial line. The axial line of a dipole is the line passing through the positive and negative charges of the electric dipole. Consider a system of charges minus Q and plus Q separated by a distance 2A. Let P be any point on an axis where the field intensity is to be determined. Electric field at P EB due to plus Q. EB is equal to 1 by 4 pi epsilon naught Q by BP whole square along BP is equal to 1 by 4 pi epsilon naught Q by R minus A whole square. Electric field at P due to minus Q of EA. EA is equal to 1 by 4 pi epsilon naught Q by AP square along PA is equal to 1 by 4 pi epsilon naught Q by R plus A whole square. Net field at P is given by EP is equal to EB minus EA is equal to 1 by 4 pi epsilon naught of Q by R minus A whole square minus Q by R plus A whole square. Simplifying, we get EP is equal to Q by 4 pi epsilon naught for AR by R square minus A square whole square. EP is equal to 2 Q by 4 pi epsilon naught 2 R by R square minus A square whole square. 2AQ is equal to P. K is equal to 1 by 4 pi epsilon naught, or EP is equal to 2 kPr by R square minus A square whole square along BP. A special case, if 2A much less than R, EP is equal to 2 kP by R cube along BP.